Hi everybody and welcome to my shop. Today we're going to be talking about measuring tools. So today we're going to start talking about measuring tools. Mainly we're going to focus on precision measuring tools and how we identify very fine measurements. But first we got to start off with the tape measure. This is the tool that we're going to use the majority of the time when we're fabricating, we're cutting stock, that sort of thing. It's widely used in many industries and we need to know how to read it right, otherwise mistakes can be made. And here's an example of one of those mistakes. In '99, an error measurement cost NASA $125 million just because somebody misinterpreted a measurement. So we need to make sure that we're measuring correctly and accurately. Let's take a look at the inside of a tape measure and how it's constructed. So there is a outer case, usually made of plastic, a rolling mechanism. The majority of tape measures have a locking device of some sort on them. And the tapes are usually made of either steel or fiberglass construction. And a very important part is the front part, which is that clip, tang, frog. There's a lot of different names for it, but it's very important that we take care of that. That's an important part of the tape measure. They're held onto the tape using rivets, and those rivets are intentionally loose, and it's very specific how loose they are. It allows the tang to move back and forward the thickness of the tang itself. That way, when we're making inside measurements or outside measurements, that tang actually moves the correct width so that our measurement's accurate. If it didn't move, our measurement would be off by the thickness of that tang. So because of that, it's very important to take care of that tang. If that tang gets bent in any way, or those rivets become loose or wallered out, then your tape is going to be less accurate than if it were nice and straight 90 degrees and at the correct tension. If you've ever wondered what the measurement is on a tape measure, if you have one, it's for a specific purpose. I personally don't use it like this, but it is an option for you to use. If you are measuring inside something like a box, you can take a measurement with the tape and then add that dimension. That dimension is the dimension of the case itself. So adding those two dimensions should give you your overall dimension. So in the United States, we use the imperial standard method of measurement. Across the world, the metric system is used widely. In fact, we're pretty much the only people that don't use the metric system anymore. So we use the feet and inches. So there's 12 inches per foot. So the first part of the tape measure is graduated just in inches. And then after we reach the 12-inch mark or the 1 foot mark, the tape measure is graduated in both feet and inches. So 16 inches, if you look at the bottom picture of this tape measure here, we could also call that 1 foot 4. So there's no right or wrong of how you call it. We just want to be consistent. So if you're going to be talking in feet and inches or just straight inches, it's recommended that you just use the same way of articulating that measurement over and over again. So don't say 16 inches one time and then 1 foot 4 another. It just gets a little confusing. And each inch is broken down into smaller graduations. So depending on the type of tape that you buy, some of these might be smaller graduations than others. The smaller the graduation, meaning the distance in between the lines, the more accurate the tape is going to be. So in this instance, and it's pretty typical with most tape measures, this is broken down into 16th graduations, meaning that each one of those lines, the distance in between them, is a 16th of an inch. And you might see with some tape measures that the first foot is graduated in 30 seconds of an inch, just to allow you to get a greater degree of accuracy. With that being said, the potential accuracy of these tape measures is the graduation distance. So we can never be more accurate in this case than a 16th of an inch. Now, when it comes to reading a tape measure, we want to make sure that the tape measure is as straight and as tight as possible. Obviously, if there's any coils or anything like that in the tape measure, it's going to lead to inaccuracies. Also, if we haven't pulled the tape measure straight across, there's something called a sine error, cosine error. where we actually get a wrong measurement if it's not a direct line between the points that I'm measuring. So in this instance, we're just going to look at the tape measure and figure out which line best lines up with our part. Now we're always going to go back. We're never going to count what we haven't gotten yet. So in this instance, we've come to 10 inches. We haven't got to 10 inches and a 16th yet, so we're not going to count that extra 16th of an inch. So in this instance, we've gone past the 1 foot mark. So we have two different ways that we can articulate this measurement. We could either call it 13 inches and a half or 13 and a half inches, or we could call it 1 foot, 1 inch and a half. So 1 foot, 1 and a half. Both of those are proper ways of identifying this measurement. Now let's see how you do with some measurements of your own. So now let's talk about when a 16th of an inch is not good enough. So we're going to get into precision measurement now. So in precision measurement, we're going to be measuring down to a thousandth of an inch. We can even go further than that, down to 1/10,000th of an inch. So in perspective, a 16th of an inch is 0.0625, and that's the accuracy we can read to on a tape measure. We're going to read down to 1,000th of an inch, which is 0.001 of an inch, or 0.0001 to 1/10,000th of an inch. So to kind of put that into reference for you, the thickness of a sheet of paper is about 4/1000th of an inch thick. So one of the things that I find is hardest for the students to understand is just how to say what it is that they're trying to say. So learning how to speak in the thousandths of an inch. We're used to talking in 16th of an inch and maybe even 30 seconds of an inch. But when it starts talking in the thousandths of an inch, get a little bit confusing. So 1,000th of an inch is 0.001. 10,000ths of an inch is 0.010. And 100,000ths of an inch is 0.100. Now you might ask yourself, 0.1 is a tenth of an inch, and that is accurate. The problem is that when we're trying to read to such small measurements, it's hard to articulate that by saying 1/10 and then 1/100th and so on and so forth. So we speak in the thousandth of an inch. The third decimal point is how we articulate our measurements. So I find kind of one of the easiest ways of describing this is when we're talking in the thousands, we're just going to kind of pretend that the decimal point's not there and just read the number as we normally would. So 001, 1,000ths, 010, 10,000ths, 100, 100,000ths of an inch. Then lastly, we have 1/10,000th of an inch, and this obviously gets confused quite often with 10,000ths of an inch. It is 1/10,000th of an inch, and that's the fourth decimal place. And typically in machining and other precision type measurement environments, we're going to be calling that out last, and I'll show you here in a second what I'm talking about. So let's go ahead and look at some measurements. So this measurement would be 1,000th of an inch. This is 10,000ths of an inch, 100,000ths of an inch, and 1/10,000th of an inch. Now, depending on the degree of accuracy that you're going to measure to, we could call this 6,000ths of an inch. It also could be 6,000th of an inch and 0/10,000ths of an inch. Sometimes you'll hear 10,000ths of an inch abbreviated to tenths. So 6,000ths and 0/10ths. This measurement would be 65,000ths of an inch, 915 thousandths, and 6/10,000ths of an inch. Here we have 9,000ths of an inch, 26,000ths of an inch, 325,000ths of an inch, and 0/10,000ths of an inch, and 9/10,000ths of an inch. And lastly, we have 250 thousandths and 1/10,000ths of an inch, 876 thousandths and 5/10,000ths of an inch, and 25 thousandths and 4 10,000ths of an inch. Now let's look at some of the tools that we use in order to measure to this high degree of accuracy. The first tool is a pretty simple tool, but a ruler, or also called a scale in machining. You can purchase these in different lengths and also different graduations. Some rulers will have graduations on both sides, say a 16th of an inch, 1/8 of an inch, 100th of an inch, 64th of an inch, all the way down to 128th of an inch. You can also buy some smaller ruler sets or smaller scale sets like this little guy here. These are little sections of scales. So there's a 1/4 inch section all the way up to a 1-inch section. And these are designed to fit onto a little holder like this so that you can reach in and take measurements in hard to reach places if you couldn't get a full ruler or something like that in there. On the other side of the spectrum is the micrometer. This is a very accurate tool. We can read to 1/10,000th of an inch with this tool if it's designed to do so, if it has what's called a vernier scale on it. So the rotating part in the back is called the thimble, and underneath that is what's called the sleeve. And I'll show you in a separate video how we go about reading the micrometer. But this is designed for taking outside measurements, meaning we can only measure outside of something with this tool. Typical micrometers have a 1-inch range, so this particular micrometer is called a 0 to 1 mic, meaning that it can read from 0 inches to 1 inches. So if you look at this bolt is larger than 1 inch, so it means I would need to get a larger micrometer. So the next one up would be a 1 to 2, then a 2 to 3, 3 to 4 micrometer in order to measure larger parts. Micrometers are pretty expensive. They're pieces of equipment. You know, a decent micrometer might set you back $100. So if you have multiple ranges that you need to measure within, it can cost you a lot of money to purchase all those tools. And we talked about the fact that these particular micrometers are designed just for taking outside measurements. So if I need to take an inside measurement, then that requires the use of a different tool. And you guessed it, it's called an inside micrometer. Now these tools operate almost exactly like an outside micrometer, but one main difference is that the way that you read these is completely opposite of how you read an outside micrometer, because the way that the spindle is moving, or the thimble and the sleeve are moving, the measurements are actually backwards from each other. So now we have two tools for measuring the inside dimension and the outside dimension of a part, but we're still missing a dimension, and that's a depth dimension. Neither of these tools can measure depth. So enter, once again, a depth micrometer. Depth micrometers are read the same way that an inside mic is read, and it's backwards from an outside micrometer. But they do have one advantage over some of the other micrometers, in that all the other micrometers that we have typically have a 1-inch range. Depth mics, when you purchase them, they come with different rods. So you can remove the rod out of there. This is a 0 to 1 rod. And I can get a 1 to 2 rod, and I can slide that into the micrometer head. And now I have a 1 to 2 inch depth micrometer. So you get a little bit more bang for your buck out of these than you do some of the other micrometers. Now the one main advantage about using micrometers over other measuring tools is their degree of accuracy. They are by far one of the most accurate pieces of equipment that we have. But the next piece of equipment we're going to look at is a little bit more versatile. It's the caliper. Calipers have some distinct advantages over micrometers. Ease of use is one, and then also flexibility. So there's a couple different things that we can do with this one measuring tool that we can't do with micrometers. So this particular one is called a vernier caliper. It uses a series of lines that you line up in order to make your measurement. You'll see how the vernier scale works in another video. But the benefit of calipers are we can take external measurements just like with an external micrometer. We can also use these back jaws to take internal measurements, which would require a separate micrometer to do. And then lastly, we can also take depth measurements using the back end of this. There's a rod, a depth rod that comes out the back end of the caliper. So it's quite flexible. This is another type of caliper. This is the style that you're going to use in the shop. This is called a dial caliper. So on the dial caliper, there's a graduated ruler on the frame and then also a dial, and every revolution of that dial constitutes 1/100,000th of an inch. And this style of caliper is a lot quicker to read than a vernier style caliper. And lastly, we have a digital caliper, which obviously by far is the easiest to read. They're also pretty expensive to get a good one, and they're more prone to breakage though, so you have to be a little bit more careful with these. And then one of the other main advantages of using calipers is their range of measurement. So these particular calipers are 6-inch calipers, meaning you can measure from 0 inches up to 6 inches. So sometimes when we're measuring, we need help. We can't take a measuring tool to the exact location that we need to measure from, or sometimes we want to turn an internal measurement to an external measurement. So for those we call helper tools. And one of the helper tools that we're going to use is called a telescoping gauge. And one of the key features of a helper tool is that it doesn't give us a direct measurement. So it's something that we're going to use to kind of transfer a measurement from our part to our measurement tool. How these work is we select the telescoping gauge with the right range for the hole size that we're going to be measuring. And these are spring loaded, so these little T part at the end will expand and contract. So we push them in, and by twisting the end we can lock that shut. Then by inserting that in the hole, we can release those arms, let them find the sides of the hole, tighten it back up again, and then when we remove it, we can take our micrometers and we can measure over top of that. So we've effectively just turned an inside measurement into an outside measurement. Now, sometimes the holes that we're trying to measure are smaller than what the telescoping gauges are. So for those, we have a different helper tool which operates pretty much the same way. Those are called a small hole gauge. So we're going to find the ball with the right range, and these ones just have a little wedge-shaped drawbar in there that as I tighten up the drawbar, the wedge opens up the ball. So I'll use that pretty similarly like I do with the telescoping gauge inside the hole. Swell it up until it fits, and then pull it out and measure it. The last helper tool that we have is called a caliper, not to be confused with the calipers we already talked about. These do not allow you to direct read on them. They're just used just like the telescoping gauges and small ball gauges to transfer measurements. And you can see that there's two different styles. The one on the right is an inside caliper for taking inside measurements, and the one on the left is an outside caliper. I'll use these on the lathe. I'll set the outside caliper to a specific diameter, and then I can use that to kind of check to see if I'm reaching that diameter or not, kind of as a feeler gauge. And the last measurement tool that we have, sometimes we need to measure angles. So there's a couple different tools that we can use to do that. This one is a simple protractor. Protractors give us angular measurements in degrees. Degrees can actually be broken down further into minutes and seconds. That's how we measure angles. So with this one, we're going to just open it up and use the arm and kind of that flat face up against our workpiece to determine the angle. You'll notice that there's two angles noted on each side. That's the obtuse angle and the acute angle. So here's another protractor head. Now this is a little bit more advanced protractor head, and this one has a vernier scale on it. So that vernier scale actually allows us to measure to the minute of an inch. We can't measure to the second of an inch, but we can read down to minutes of an inch with this particular one. It's a little hard to read on there because this is kind of an old guy. And if you have a combination square, you can get an attachment like this. This is a protractor attachment for a combo square. So if you take off the squaring arm, you can attach this head to it. This doesn't have a vernier scale on it, so this is just accurate to degrees. But it's a little bit larger, a little bit easier to use on larger parts. So I hope you've learned something today about measurement, about the tools for measuring. In another video, we'll talk about how we use these tools. Have a great day.